Hi, Code with JS. Well, the idea behind this channel is to use JavaScript to build data structures and algorithms. I was studying about the same and I felt a huge lack of resources which taught data structures using JavaScript. So today we would be looking at our first data structure, singly linked list. Then we would try to make an array implementation using a single linked list and would cover the common properties an array gives us. So enough of talking, let's code in JS. So I would be using VS Code for doing the same. Okay, so just let me quickly see whether I'm able to log things out to the console. Okay, great. So first of all, let's see like linked list, what exactly a linked list is and what exactly a single linked list is. So a linked list is a data structure, and the special property about a linked list in comparison to an array is that an array consists of consecutive blocks of memory. So while a linked list consists of randomly distributed blocks of memory. Okay, this is the main difference between an array and a linked list. Okay, now we'll see what is the structure of a linked list looks like. So a linked list starts with a head node. Okay, and use this symbol to represent a pointer. Okay, so in C language you have pointers. Okay, but in JavaScript we have objects, and objects are by reference in JavaScript. So whenever we point to an object, we are actually pointing to its reference. Okay, so that's a way to make a pointer in JavaScript. Okay, so a head node consists of a pointer called next. Okay, so we'll represent our head node with head, and it points to null at the starting when our linked list is totally empty. When our linked list has some data, okay, then we have a node. Let's call it first node. So when we add a node to our linked list, so it's our the next of our head node would point to the first node, and first node would also have a next pointer similar to the head, and that would be pointing to null. So that's the idea of how a linked list is constructed. If I would add another node, so say a second node, then the next of head would be pointing to first node, the first node next would point to second node, and the second node next would point to null. That's what a singly linked list is. So in a singly linked list, it consists of a head node. Head node is nothing but a pointer which just has a pointer to the first node. Then we have nodes, which we are symbolizing by first node, second node. A node consists of a value and a next pointer to the next node. And our linked list ends when there is no more nodes, or the next of the last node is pointing to null. So that marks the end of our linked list. Easy. Okay, so the two elements which comprises of our linked list are head and node. So let's just construct these two basic elements and then we'll move from there. So let's make a node, and a node consists of two elements, value and next, and I would like to change this. So this dot value is equals to value. This dot next is equals to next. So basically what I've done, I have made a constructor function called node. It receives two arguments, value and next. So this is our representation of the node, and it has two properties, value and next, and whatever value we would pass on the argument would be set as that property of the node. So that's our node, bare bone node. Okay, let's just follow the same behavior and declare our head. So as I told, head consists of only a next pointer, no values. So our head would have this dot next is equals to next. Cool, right? Okay, so once we have our bare bone elements in place, let's try to somehow construct a simple linked list out of it. So let's call it linked list, or let's call it, because it's a singly linked list, a singly linked list. Okay, so the first thing which our linked list needs is a head node. Okay, so we already have the constructor function for the head, so we would just use it to construct our head. So const head is equals to, sorry, this dot head is equals to our new head. And since when the node is initialized, the linked list is initialized, the head points to null, so we would pass null as the value of the next pointer, right? So I think this would result into what we need for initializing our linked list, empty linked list. But there is no way to log it to the console, so I would make a function toString, and this toString, what it would do, it would just console out what we want, or what is the current state of our linked list, to the console, and this should do it. Okay, so our toString, what I'm doing in my toString, I am just json.stringifying the object, which is my this. So this consists of head. Okay, and head consists of this head node, so next. Okay, so because it's an object, so I have to in order to print it, I have to stringify it. So that's what I'm doing. So let's just test it out, like what we have done, whether it's working or not now. So I need to make a let's call it my list. And just log it out using our toString method. Let's run it. And yes, great, awesome. So far so good. So this is what we wanted. So we have a head node which just has a next pointer and it is pointing to null. That's what we wanted out of it, out of our linked list. Cool. So let's move to the next thing. Okay, So the next thing is like we want to add some element, add some node to our linked list. So since we also want to make a array implementation using the linked list, so we would name it like push. So array has a push operator, which what does the push operator of an array do? It just adds whatever element you give it to the end of the array. Okay, so we would make a similar implementation. So it would it should look like this, right? And if I would be adding another element, it should look like this. Yeah, so that's what our push should do. So let's make a push function. So push would need a value, the value which is to be pushed. So let's call it value, which would be our argument. Cool. Yeah. So okay, how can we push? Let's think about it. So our linked list has a next pointer. Okay, so in order to push, first of all, we would have to make a node, empty node with a value. So we have this constructor function of node. This would help us to make a node, and it would have a value and a next. So the value we are receiving in our push function, that we can pass over here, and next would always be null. Why? Because we are using push. So push always adds an element at the last, and the next would always point to a null. That's the definition of a linked list. Okay, so this is sorted. Next, what we need to think about is that our head node is pointing to null right now. So when we push, we need to point the next of the head node to our new node, which we have created. So if we would do that, so then this linking would be like perfect. It would be possible. Yeah, so that's the idea. So let's try to write some code for the same. Okay. So how I would like to write it, like cover all the operations one by one. So supposingly right now the state of our linked list is this. Okay, so suppose we want to add a first node, so we would just do that, and then we would like iterate over a solution and make it more generic for adding n number of nodes to the push. Okay, so mhm, okay, so this dot head, yeah. Okay, so if this dot head dot next, this dot head dot next is pointing to null right now. Okay, so this would be the condition that we want. Okay, so this gives me the condition when our linked list looks like this. Okay, so we are trying to push element for the first time on a empty linked list. Okay, so easy. Now this dot head is this dot head dot next, which is null, should point to a new node. Okay. Mm-hmm. Mm, okay, and our node is this. Okay, so new node, and what is the value we are getting? We are getting value comma null, because our node is null. So if our this dot head dot next is null, then we would just point it to the new node, which is being created over here. Yeah, and yes, so just let's test it out. So our node was null. Let's set another console and my list dot push 0. Let's see. Mm, and yes, it worked. Great. So our head dot next was null, and now our head dot next is pointing to a new node which has a value 0 and the next node null. So far so good. It's working as we thought it would be. But would this logic still work if I would add another value or the second node? Let's see. Now we are only pointing head.next to the new node. Okay, so it would work for the first time. Okay, but the second time this dot head dot next would not be equals to null, because now it is pointing to the first node. So we need to make a else condition which would cater for now any subsequent pushes that would be happening to our node. Okay, so let's make a variable called current node, and we would put the value of head.next inside it. So this dot head dot next points to our first node right now. Okay, so right now this is already there. Okay, and what we are trying to do is we are trying to push a second node. So this dot head dot next would give us our first node, which is, and we have called it the current node. Okay, and because what we actually want to do is what we did for hext head the last time, we need to make a new node which would point to null, and we should somehow put the pointer of first node, which is pointing to null right now, to point to our second node, and our linked list should be good. Okay, so we have the current node. So current node dot next, right, should be equals to this new node. Yes, I think it would work. Let's run it. Okay, let's check the output. Head next 0, next 1, next null. Perfect. So far so good. Awesome. Cool. So we made a generic push on our single linked list, right? But is it generic enough? If I would add a third node, would it still work? Let's see. So okay, should work. Let's try to run it out. Okay, so it work or no? Okay, so it did not work, because what happened, it added 0, it then added 1, and on the same index, because we are still pointing to this dot head dot next over here, it changed the value of 1 to 2. So we need to add something more to our solution, because the problem over here is our current node is always this dot head dot next, so it's always first node. So what we need to do is change our first node to second node now, because that's what we want. So in order to do that, obviously we would need to iterate, because we cannot put this dot head dot next and then this dot head dot next dot next dot next. Okay, this would be like a bad code. So let's try to iterate over it, and that should do our job. So basically what we want is, we always want our current node to be the last node that was added, or which is pointing to null. Okay, so yeah, we can use the same logic. So let's iterate over our current node until we find null, and that would give us our last node, and then we can go from there. Okay, so I would be using a while loop over here. Current node dot next. Okay, so first time when one was added, the first node was added, current node dot next would be null, because it's pointing to null, and this condition would not be satisfied and it would work. The second time, current node dot next would be sorry, second time, and the third time, current node dot next would not be equals to null, and what we need to do is make our current node as current node dot next, and yes, I think that should work. So what have I done? I have just changed this counter, so our counter was pointing to this dot head dot next. Okay, so this dot head dot next is first node, our current node. Okay, and supposingly if our list right now looks like this. Okay, so what would happen? My current node dot next is not null, because it is pointing to second node. So it would come inside, it would see my current node dot next. What is that? So current node dot next is second node, and it would assign onto my current node, which is right now first node, the new node value, which is second node. Okay, and now my current node has iterated over to the next node. So my current node now becomes second node, which is pointing to null, which is the last element. Okay, and now our logic of current node dot next would work. Why? Because now my current node dot next is null, and I would just make it point to our new node, which is third node. Okay, let's run it, and hopefully it would work. Let's see. Okay, we got 0, 1, and 2. Cool, so it's working. Let's test it out. For what if we add another node to it? Would it still work? Okay, 0, 1, 2, 3, and 3 is pointing to null, so great. So now our push function is, I think, generic enough, and it would work for n number of nodes. So now it can handle any number of nodes that are added to it. Great. Okay, so now what is the next operation that array provides? suppose pop. Okay, so what does array.pop does? What array.pop does is it takes the last node out of the array and it mutates the array. So it changes our array from this to this. Okay, so that's what we need to make now. Okay, so what should we do for that? How should we do that? I think the we can keep most of the logic similar to push. We need to iterate over. Okay, find the node which is pointing to null. Okay, and just remove that node. How can we remove that node? So how can we remove that node is if we would say to the node previous to the last node to point to, instead of this, to directly point to null. So if we would do that, this node would become unreferenced, and then it would be garbage collected, and our linked list would actually become this, and our pop operation would be successful. Okay, yeah, so that's the idea behind it. Let's try to implement the same. So this dot pop doesn't receive any value, so we would like just make it like that. And so let's think about the pop just like we thought about push. So what if our node is empty and someone is trying to apply pop over it? Okay, so it would not work because there is nothing to pop, right? So we should like throw some error or give some meaningful error message to the user that it's not possible because our list is empty, right? So let's just do the same. So this dot head dot next, which is the similar condition what we used over there. So if this dot head dot next is null, okay, and someone is trying to pop, so we can just throw an error, uh, list is empty. Okay, cool. Okay, so that handled our like blank node. Okay, what if this case is what we are looking into? So our node consists of just one value. Mhm. So now let's like write like if, or first let me find the pointer. So the current node, this dot head dot next. So we have already checked on this dot head dot next is not null. So now I can find the value of this dot head dot next, and then I can check if it has a next. Current node has a next. So current node next. If current node dot next is not equals to null, or it's null, so that means it's this case, then we just need to pop this value out, and it should be like easy. So also like pop operator in an array also returns the popped value. So we also need to take that into account. So we can just make a temporary variable. Pop value is equals to current node dot value. That would be our pop value, and we would just return it. And we should also change our array before returning. So we would just point this dot head dot next to null. Yeah, and that should do a job. So we would remove this first node and our head would directly point to null. Okay, this would change our linked list, and we have also returned the popped value. Okay, let's try to run it out and see whether these two conditions are working or not. And for that, let me just comment this piece out and just try to do my list dot pop. And okay, yeah, so we got an error, which was intentional in this case because we are throwing error. Cool. So this works because right now this operation should result into an error because our list is already empty. Great. Now let's test this second case where our linked list has a first node. So just a second to check everything. I have to run it like that. Okay, so the first console shows us our initial node, then we push the value, so we had a 0, a new node which was added, and then we pop the value, and our console.log showed us the new state. So yeah, this is working, but uh, we did not check whether our pop is returning a value or not. So let's just put that also in a console like that and just run it. Great, brilliant. So yes, it's working. So our pop is working till now. Okay, so yeah, now let's move if to the next logic where our list would have like n elements and we need to pop values out of them one by one. So now if I would run the same code over this where our linked list has a first node and a second node, it would obviously not work because I am checking for empty linked list and I'm checking for a linked list with only one node. But over here, our current node dot next would not be equals to null, so it would like not pop out this second node out. So we need to like think about some way of doing that in a generic way now. Okay. So we can actually use the similar idea where we would iterate over our current node and uh, find the node which is pointing to null. Okay, but this approach has a problem that our current node would be this. Okay, and since our this is a singly linked list, we don't have any pointer which would tell us like what was the last node. Okay, why do we need the last node? Because the last node has the next which is pointing to our current node, and what we actually want is this last node should point to null instead of our own node which is our current node. Okay, so a way to solve that is like maintain the last node also while you are iterating. So that's what we would also do. So we already have a current node, okay, which we are maintaining, which we were maintaining. So let's also make a variable called last node or previous node. Okay, and then we can just do current node dot next. Sorry. Yeah, where was I? Looks fine now. Okay, yeah. So current node is equals to current node dot next, and with that we also need to store some value in our last node. Okay, so last node, what last node would be? Last node would be our current node. So the idea is while we are iterating over nodes one by one, okay, so why we why we did not add this condition over here only and we wrote this separately out? Because over here our last node would not exist, because when we are on first node our last node actually is head. Okay, and head is not actually a node, it's just a pointer to our first node. So that's why we have to write it like that separately. And now once we have iterated over our head and first node and our current node is like actually the second node, now we have a last node, actual last node. So yes, so yes, so and when we would be here we are saving that onto the last node and iterate and putting the current node as the current node dot next, which is second node, and the next time when the would run, current node dot next would be null, so it would not go any further, and our last node would be first node and our current node would be second node. So we have values for both our nodes, previous and current, and that's what we wanted. And now it's like the similar logic which we wrote over here. So we would make a const called pop value, and we would assign current node dot value to it. We would return it. I don't know why am I doing this. We can just directly do this. Okay, yeah, and what else? Okay, we returned a value, but we did not change the pointer. So yeah, that's what we made the last node for. Okay, so last node dot next is equals to null. So we're using a similar logic that we did for head. but we are just finding our last node. Okay, yeah, so let's run our code to see whether what we want is working or not now. So in order to run, yeah, let's run it. Mhm. Okay, so we had like two values, 0 and 1, and now the popped value is 1, which was the last node, and we had 0, next, null. Cool. So our pop worked. Let's test it out for a bigger array for more values, just to be sure whether it's working properly or not. So now we have 0, 1, 2, 3, 4 values, and I would just put it 4 times like that. So pop, 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 pop. So see, this would be removed, this, and then we should. Okay, let's run the error one separately. Let's see. Mm-hmm. So it worked absolutely correctly. Yeah. So our array had like, or sorry, our linked list had like 0, 1, 2, 3. Okay, and we popped values, and pop removes value one by one from the last. So the first value which was removed was 3, 2, 1, 0. Great. And now our list is empty. And now if we would try to pop again, we would get that error which we are throwing. Cool. Great. So I would say like that's it for today, and we have covered push, pop, and we have just made a single linked list, a basic single linked list. Uh, we would still cover some more operations that our array provides us on our single linked list. Those would be namely like for reading some value at a specific index, writing over that value, and then we would try to make a a utility function that array provides us like array dot reverse. So we would try to reverse our linked list. Okay, so let me know how did you like the video, what can I improve over it, and if you like it, just you know like the button, put hit the like button, subscribe it, and yes, that's for today. That should be done. Thank you.